Probability problems using combinations. A shipment of 120 amplifiers contains 4 defective speakers. A plant manager will randomly inspect 5 of them. What is the probability that exactly 2 speakers will be defective? So there are a couple different methods. One is a bit what I call old school, the stuff we've already learned before. It will still use combinations, but it'll use more of the techniques that we talked about before. And the second method will use mainly, if not only, combinations. So let's look at the first method. And let's set up some information. Notice that we have 120 total amplifiers. There are 4 defective, which I'm going to call bad, which means that there are 116 that are not defective, which I will call good. A plant manager is going to randomly inspect 5 of them. So we have 5 choices. So using the probability ideas we did before, we need to multiply 5 things together. What is the probability that exactly 2 of the speakers will be defective? So let's start writing it out. What is the probability that the first speaker we choose is defective? Well, we know that probability is how many we want, in this case bad, out of how many total things there are. What is the probability that the second speaker we choose will be defective? Well, there are 3 bad speakers left out of 119 total left. Now, we're not done because we're choosing 5 speakers, which means if the first 2 are bad, then the next 3 must be good. So what's the probability that the third speaker is good? Well, there are 116 good ones left out of 118 total. What is the probability that the next speaker we choose is good? Well, there are 115 good out of 117 total. And what is the probability that the fifth speaker is good? Well, there are 114 good ones out of 116 total left over. Now, you might think, well, that's the answer. But is it really? This means that the first 2 were bad and the next 3 are good. But is that the only way we can get 2 bad out of 5? Well, no. Because it could be not only the first 2, it could be the first one and the third one, or the first one and the fourth one, or et cetera, right? So how do we count the number of different ways we can choose 2 bad out of 5? Well, that's going to be a combination. So this back part is assuming the first 2 are bad and the next 3 are good. But then we can order them in different ways, right? And we're going to order them with a combination. So if we type all of this into a calculator, we get about 0.008. Now, there's a less than 1% chance of choosing exactly 2 speakers out of 5 and finding them defective. Now, this is certainly not a bad way. I like this way because it helps me understand probability kind of at its basic. But let's talk about another way that you might like, which is a little bit harder to understand, but it's a little bit quicker to do. Once again, probability is the number we want, or how many things we want, out of the total number of things that there are. So is there a quicker way to get right to this? Well, here's my claim. Let's start by doing the total number of things that we could get. And the total number of things we can get is what? Well, it's choosing 5 out of 120. So the total number of things, that is 5 group things that we could have, is 120 combination 5. It's a total number of 5 unit things that we can choose out of 120. Now, how about the number of things we want? Well, we want 2 bad, right? We want 2 bad out of how many? We want 2 bad out of 4. So 4 combination 2. But we also want 3 good out of however many good we have. So we want to choose 3 good out of the 116. And if we type this into our calculator, because I am using the built-in formulas to do this, we get the exact same value. Let's do one more example. We'll do it both ways. As of the recording, the United States Senate had 53 Republicans and 47 Democrats. Committees of 7 people are to be formed. What is the probability that a committee will randomly select 4 Republicans out of the 7? So the first method, kind of the old way of doing things, is the following. I'm going to start by assuming that the first 4 we choose are Republicans. So the first choice, there are 53 Republicans out of 100 senators. Now the second one is also Republican, so we'll do 52 left over out of 99 senators total left over. And then the third one, Republican, there are 51 leftover Republicans out of 98 leftover senators. And then the fourth one was Republican as well, so 50 out of 97. Which means the next 3 must be Democrats. So there are 47 Democrats out of 96 senators total left over, meaning the 5th person chosen is a Democrat. And then the 6th person is a Democrat. There are 46 Democrats out of 95 total senators. And finally, the last one, Democrat, will give us 45 out of 94. But that's assuming that the first 4 are Republican, and then the last 3 are Democrat, right? Is that the only way we could choose 4 Republicans out of 7? Well, no. How many different ways can we choose 4 out of 7? That's our combination. So if I multiply all of these things out together, I get the value of about, I'll put equal sign here, 0.297. So a little bit less than a 30% probability of this happening. Let's look at the other method, which is in general the method that I would use, just because it's quicker. So we're going to do a similar thing where in the denominator is going to be the total number of 7-person committees. Well, there are 100 different senators to choose from, and we're going to choose 7 out of the 100. So that's the total number of committees we can make. How many different ways can we choose Republicans? Well, there are 53 Republicans, and we're choosing 4. And then there are 47 Democrats. I put R for Republican. Let me fix that really quickly. I, of course, meant C. So there are 53 ways of choose 4. That is, there are 53 combination 4 ways of choosing 4 Republicans out of 53. And then there are 47 combination 3 ways of choosing 3 Democrats out of 47. And if we type this into our calculator, we get the exact same value.